Okay, welcome back. This is Mr. Hassan's Maths channel, and this is a question I'm answering from one of the UK papers from June 2018. This is the Edexcel GCE paper 1. This is from the AS paper, and this relates to what we do in P2 in AS of International A-Level Edexcel. Same kind of stuff, just some extra practice here of some trig equations, which some students I see have some issues with. So I'm going to go through and try to explain, especially in part B, in more detail, how to solve trig equations in an easy fashion. Okay, so now, first of all, they've told us to show that 4 cosine theta minus 1 equals 2 sine theta tan theta can be written in this form. So I've got to take this and rewrite it in that form here. So we can see here that in the original equation that we've got cosine theta, sine theta, tan theta. In what we have to form, we only have everything in terms of cosine thetas. There's a squared, and there's no sine and tan theta in it. So what I'm going to do is I'm going to leave the cosine theta as it is. So 4 cosine theta minus 1 equals. Now, we have two identities in P2 that we are aware of. One of them is that tan of an angle is equal to the sine of the same angle divided by the cosine of that same angle. And the other one is that the square of sine theta plus the square of cosine theta, which is written as sine squared theta plus cosine squared theta, is always equal to 1. So if you have the sine of an angle squared, if you have the sine of an angle and you square that, and you add to that the cosine of that same angle but squared, it will give you 1 always. All right, so what is very important for us to realize that this is not true. This is not true. This is something which a lot of students, they think you can just take this, they think you can take the square root of both sides. They say, oh, why is it not true? Because it's like just taking the square root. No, I know 3 squared plus 4 squared equals 5 squared. That's true. 9 plus 16 equals 5. But does that mean that 3 plus 4 equals 5? Of course not. Right? So you can't just say take the square root of both sides. When you have two separate terms squared and added, you can't just do that. Right? So that's not true then. Okay, this is not true. So that just in the same way, this is not true, that's not true. So it's, if you take the sine of an angle and you square that, and then you take the cosine of that same angle and you square that, then it equals 1. The sine of an angle plus the cosine of the same angle doesn't equal 1, but the sine of an angle squared plus the cosine of the angle squared equals 1. So that's important for us to realize. So what I'm going to do here is I see that from these two identities that I know, the only thing really I can mess around with here is a tan theta. I can replace the tan theta with sine theta over cosine theta. So let's see how that helps us. So we have 4 cosine theta minus 1 equals 2. I can't do much with the sine theta here, but this becomes sine theta over cosine theta. Okay, now I want to get rid of this fraction. So what can I do? Well, I can multiply both sides by cosine theta. If I multiply both sides by cosine theta, on this side I'll have cosine theta times 4 cosine theta minus 1. And here you'll end up with 2. You'll have sine theta times sine theta, which is sine squared theta. Remember, sine theta squared is just written as sine squared theta. That's what it means. It actually means sine theta times sine theta. That means that. So this means the same as sine theta times sine theta. So I've multiplied both sides by cosine theta, and now I have something which I'm looking a bit more familiar. I'll expand this side. So cosine theta times 4 cosine theta is 4 cosine squared theta. Cosine theta times minus 1 is cosine theta equals 2 sine squared theta. So now I'm getting somewhere. It's looking a bit more like this, but the only issue now here is that here I have a sine squared theta, and there's no sine squared thetas or sine thetas in it. It's all in terms of cosine squared theta and cosine theta. So what I can do is I can use this identity that we have here, and I can rearrange it. So I want to replace the sine squared theta and replace it with something in terms of cosine squared theta. So if I rearrange this formula, I know that sine squared theta is the same as 1 minus cosine squared theta. So this identity can be rearranged, and I can replace the sine squared theta with 1 minus cosine squared theta, which will help us here. So you have 4 times cosine squared theta minus cosine theta equals 2 times 1 minus cosine squared theta. Now when I expand this, I'm going to get something which is going to help us. So cosine squared theta minus cosine theta equals 2 minus 2 cosine squared theta. Now we have everything on one side of the equation. It says equals 0 on the other, so I'm going to do that. I'm going to add I'm going to subtract 2 and add 2 cosine squared theta to both sides, and I'm going to show all the steps very clearly because this is a show that question. So you have to be very careful to show all your steps. So I have 4 cosine squared theta minus cosine theta minus 2 plus 2 cosine squared theta is equal to 0. So now I can combine the like terms. I have 4 cosine squared theta plus 2 cosine squared theta, which is 6 cosine squared theta minus cosine theta minus 2 equals 0. And that's exactly as we have to show. Okay, so this is as required. You can write as required if you want. That's fine. So when it says show that, okay, show that or prove that, okay, you can't just, for example, I can't just write this down and then skip all these steps and then write the answer. So the examiner knows, I should know how I get there. No, you have to show the steps very clearly, how you replaced, how you first changed, the tan theta for sine theta over cosine theta. Okay, and then how you multiplied both sides by cosine theta, how you changed the sine squared theta for 1 minus cosine squared theta, how that simplified and gave what's required. It's very important that you show your steps very clearly when it has this show that type of question. Okay, so that's the answer to part A. Now for part B, it says hence solve for x between 0 included up to 90 not included, this equation here. So if I'm going to take this, I'm going to take what we had before. Okay, so this is what we were showed before, that this becomes that. Okay, this can be rewritten in that form. That's what we had to show. Okay, that's from part A, and hence means using what we did in part A. So what we can see is we compare these two together: 4 cosine theta, 4 cosine 3x, minus 1, minus 1, 2 sine 3x, tan 3x, sine theta. So basically here what we can say is the theta has become 3x. If the theta became 3x, then this can be rewritten as 6 cosine squared 3x minus cosine of 3x minus 2 equals 0. Okay, so the theta has become like 3x. So I have to solve this equation, and I have to find the values of x which solve this equation, but between 0 and 90 degrees. Okay, so now first things first, I'm going to rewrite this equation because I see this is like a quadratic equation. It's called a disguised quadratic. It's in terms of cosine, but this term is the square of that term. It's like a quadratic equation. So if I take, for example, cosine of 3x, the cosine of 3x, and I call that, for example, b, right? So this will be minus b, and this will be 6b squared minus 2 equals 0. So I have a quadratic equation which is a bit more familiar in terms of solving. So now I'm going to factorize and solve this equation if it can be factorized. Let's just do a quick check. So we're going to have 6b squared and minus 2. So two numbers multiplied to give you minus 12b squared. And when you add them, you get minus 1b. Well, that's 4 and 3. And it's going to be negative 4b and plus 3b. Those multiplied to give you negative 12b squared and add give you minus b. So yes, it can be factorized. The common factor of these two terms is 3b. And 3b times 2b is 6b squared, and 3b times plus 1 is 3b, and 2b times minus 2 is minus 4b. So we end up with 3b minus 2 times 2b plus 1 equals 0. So you end up with your two solutions. Either 3b minus 2 is 0 or 2b plus 1 is 0. So that means b is 2 over 3 or b is negative a half. So we can say therefore that the cosine of 3x equals 2/3, or the cosine of 3x equals negative a half. And we need to solve our equations between the limits of 0 and 90 for x. So you have 0 less than or equal to x less than 90. Okay, in degrees. And we have here 3x, not x. So what we need to do, we need to change these limits to 3x. In that case, what we can do is we have to also extend these limits. So this becomes 0. This becomes 3 times 90, which is 270. So that means if we catch all the angles between 0 and 270, okay, then in the end our answers will be correct because we have to divide our answers by 3. Here we'll have 3x equals 3x equals. So the first thing we do is we use our calculator in degree mode to find out what the inverse cosine of 2/3 is, and we can get the solutions for this. So I'm going to take my calculator, make sure that I'm in degree mode, which I am. I'm going to put inverse cosine of positive 2/3. And then I'm going to find out what that gives me. It gives me 48.1896. So you got 3x equals 48.1896. Just wrote it to a few decimal places. What I'll do is also store this as A. This is my calculator in case I need to use it again. Now, for the cosine curve, there are two solutions, okay, between 0 and 360. Okay, the first solution is given by the calculator, which would be this angle over here. There's another angle over here, which is also sharing the same cosine ratio, which your calculator doesn't give you. Okay, you can think of it in terms of the cosine curve. So it's going to be basically 360 minus this angle, because this distance is 48.1896, and because symmetry, that's also 48.1896, and that's 360 degrees. So this here will be 360 minus that. Or we can think of it in terms of the quadrants. The cosine curve, cosine is positive in these two, and this ratio is a positive ratio. This is the first angle, 48.1896. And we're going to go all the way around here, which is going to be basically all the way around here. This angle is also 48.196 because it's the associated Q angle. So it's 360 minus that angle. So in the end, you're going to get 360 minus this 48.1896. What I'll do is I'll write it down here so that I've got more space. So that's 360 minus 48.1896. Now, the question is that in our range? I don't think it's going to be in our range, okay, because we do 360 minus this answer, and it's 311.81. That's 311.81 something. So it's out of our range because we have to only go up to 270, which is here. So we could have seen that actually even from this graph, that we're only going up to 270. Okay, so we don't go that far. Okay, but that's how you would find it if you needed to find it. But this is out of range. This is out of range. So in this case, you got 3x equals 48.1896. 1896. I'll leave it like that for now and finish it off later in a minute. Now we got cosine x equal 3x equals a half. So 3x equals inverse cosine of negative a half. Now the cosine is negative in these two quadrants. So if it was a half, it would be 60 degrees. So this is going to be 180 minus 60, which is 120. So the calculator will actually give us that. The calculator will give us that. Okay. So we got inverse cosine of negative a half. And we'll see that the calculator gives us 120 degrees. That's the principal solution for the cosine. Now the other solution is going to be 360 minus this. So 360 minus 120 for the same reason that I mentioned earlier. And that's 240, which is in the range. So you got 120 and 240. Both of these are in our range. Our range goes up to 270 because here, the angle we just found is in this here where cosine is negative. Remember, ASTC, cosine is negative in these two. So we're looking for this angle here, which is a 120. And we're looking for the angle over here, which is 240. Okay, which is like 360 minus 120. All right. So that gives us our answer, two answers there. So we end up now with 3x equals 120 and 240. Those are the only two solutions from that one. So now we can find what x is. We have to divide both sides by 3. That's 48.1896 divided by 3. And this is x equals 120 divided by 3 and 240 divided by 3. They asked us to find to one decimal place. Okay, these two are not appropriate. They're integers, so there's no need to put them to one decimal place. But this answer here, which is now, which is this answer. Oops, what am I doing? The answer that we've got here is this, right? That we have to divide by 3. So that gives us 16.063. 16.063, which gives you 16.1. And this is going to be 120 divided by 3, which is 40, and 240 divided by 3, which is 80. So we have 40 degrees exact and 80 degrees exact. No need to write these to one decimal place. And there's the answer to this question. Okay, so when it does say, where appropriate to one decimal place, so for the ones which end up as integers, it's not appropriate to write them to one decimal place, but the ones that are, decimals that you need to round them, that's what you need to round to one decimal place. So you don't write this as 40.0 and 80.0. Okay, that's what it means by where appropriate. So that concludes this question part B. Okay, so for the cosine curve, it's very simple. The first solution is found by using your calculator. The second solution is always 360 minus the calculator answer. And then all other solutions, if there were more solutions, in this case there's not, but if there were more solutions, you would then just keep on, those angles will repeat every 360 degrees. Okay, so that's how you deal with the cosine curve. With the sine curve, I'll make some more videos to show how to deal with the sine and the tangent as well. I've got some in a playlist, you'll be able to see them, but maybe I'll make a few more to practice. So that concludes this question, which is number 12 from the June 2018 GCE AS paper from the UK, Edexcel. The other questions from this paper, if I get to answer them, will be in the playlist over here. And questions dealing with trigonometry from P2, because this is from our P2 IAL syllabus, will be in this playlist over here. You can subscribe to my channel by clicking on this link, and over here you'll find a link taking you to a video which explains how to use my channel properly, in an efficient way. Thank you for watching, and see you soon.